I'm Logan from Kustrek Engineering, here to talk to you about gas metal arc welding. Gas metal arc welding is an arc welding process that creates an arc between the workpiece and a continuously fed solid electrode. Okay? And what's going to happen here is that this continuously fed electrode is fed through this gun, and it's going to be run through a contact tip, and the electricity runs through a liner and into this contact tip and is energizing the wire as it passes through. There are drive rolls back at the wire feeder. They're going to push this wire through our contact tip, and we're going to have an externally supplied shielding gas. So when we talk about our gun, we see we've got a diffuser on here, and these holes are where our gas is going to run through our liner and going to provide shielding gas from our atmosphere. So our contact tip is going to screw in, and then we're going to put our nozzle on. We've got a couple different diameters of this to help us get into access to joints. And this is just going to go on here, and then we are going to initiate our arc by pulling the trigger and having that wire come out. The GMAW process is commonly referred to as MIG, and if you're in Europe or in Australia, we usually refer to this as MAG or MIG-MAG. Sometimes the utilization of CO2 is an active gas, so it's sometimes referred to as metal active gas rather than metal inert gas. This is shorthand for GMAW. The great part of the GMAW process is that since it's fed through the gun, it's referred to as a semi-automatic process, and our productivity goes way up. We don't have the starts and stops that we have with other processes, and the beauty with this is that we are not going to have a protective slag like our slag producing processes. We are going to have some silica, some buildup that we're going to have to clean off of that weld, but it's definitely not to the degree that we have with our slag bearing processes. And the fact that these come on, our standard is a 15 kg spool, 33 pound spool, that we get really, really good productivity. If you're looking in an automated setup or robotic cell, you can get 55-gallon drums full of filler metal. And if you're the home hobbyist, you can get these in 10-pound spools as well. When we talk about the GMAW process, we're going to use a constant voltage power supply. And for the most part, we're going to be running on the DCEP, okay, direct current electrode positive for our polarity. And what we're going to do is have our constant voltage power supply is going to keep our voltage as constant as it can and stabilize that arc. Our advantage of this process are whatever material you can buy a filler metal for, you can weld with. Okay? The great part is that we don't have a lot of stub loss. We have some clipped ends that we'll have our ends that we need to trim, but the deposition efficiency compared to other processes is much greater, and we're in the middle range of deposition rates. We're really good. The other thing too is this is really a good process to get started on. It's not extremely complicated. We can go to our local hardware store, pick up this particular power source, and this filler metal is readily available. Our big disadvantage is, especially in the short circuit transfer mode, that the process has a problem with interbead lack of fusion, where the filler metal melts and it doesn't completely fuse with the base metal or the subsequent filler metal passes. The other is that we're going to use an externally supplied shielding gas. So we're going to have a procurement mechanism. We're going to have some sort of blocking for wind, whether our max is about 5 miles an hour for cross breeze to well with this process. And we're going to have somewhere to safely chain up those cylinders or some sort of gas delivery mechanism. So that kind of can potentially limit our utilization. This is found heavily in fab shops, shipyards, and general fabrication. The other thing is that we need to worry about maintenance, make sure our nozzles are clean to not get any blocking of our gas flow. The other is our contact tips wear out. We can have core fusion. So we need to be careful on how we apply this process. However, as long as you can buy a filler metal, this is particularly our 70S-6, or a stainless, or a nickel, or whatever's available on the market, you can weld that material. It's really fantastic, all right? Thank you for spending a little bit of time with me today talking about the gas metal arc welding process.
Before we go to weld, for GMAW, we've got to set our machine up. As always, we're going to turn our machine on. And we're going to let it think a little bit. This machine in particular is a straight CV machine, so it only does constant voltage. Underneath these little flaps here, we've got a positive terminal and a negative terminal. Since we're running GMAW, we're going to be having our electrode on the positive, so DCEP. So our negative is going to run to our ground clamp that's already hooked to our table, and our positive terminal is going to be run to our MIG gun. All right, so now that she's turned on, we're going to set this from scratch just so we can go through it. So we'll hit weld. We're going to do standard MIG, just standard GTAW. We got a couple options here, but just for this, we're using the R70S-6, so we're going to choose steel. We're running our 045 diameter, 1.1 or 1.2 millimeter diameter wire. And this is going to ask for gas type. So your most popular choices for solid wire are going to be 9010 or 7525, and that's argon CO2. Okay, this particular setup is 9010, so we're going to go down here and choose C10, and we'll go there, and then we confirm. And I know that I checked our company's WPS, and it says I need to be at about 26.5 volts. And about 300 inches a minute of wire. So I've got that set. Let's get ready to weld. This is Logan again. Today we're covering gas metal arc welding, GMAW. Got my old friend Gabe here to help us.
Glad to be here.
And we're gonna talk about what this process looks like. We got some T-joints, some lap joints set up. Our parameters right now, we're pretty high, so you're going to be able to hear that characteristic spray transfer, that spray noise. Gabe, you want to give us our first weld? We'll take a look at it. Awesome. So I noticed, Gabe, when you're welding, you had a bit of a push angle. So when we don't have a slag ring process, we usually have a push angle. You want to talk about that a little bit?
So with us not having the flux in the weld for protection, we have the shield of gas for the solid wire. So with that being said, we don't actually have slag in our puddle. So we are able to push that puddle instead of having to drag it to keep the slag behind us.
So when we're using this spray process, the spray transfer, we're going to hear that characteristic sound. You could hear when he started to weld how it sputtered just a little bit, and so his contact tip to work distance is only about 3/8 of an inch or so. So I'm going to weld one of these, and you'll be able to hear some of that. We'll take a look, maybe see whose weld looks better. Ooh. Well, you could hear from the sound just in itself that my electrode extension, my contact tip to work distance was really, really too far away. So the welding itself didn't look bad, but you could just hear from the sound, that sputtering, that popping. it means I got to do something different. So towards the end there, that sound tightened up. I had to push in real close to that puddle. All right. Gabe, you want to weld another one for me?
Sure will. And as Logan says, that's an important point too, is that from your workpiece to the contact of your tip is the right distance, usually about 3/8 of an inch is usually what I run it at. Everybody has a little bit different. It's usually a personal preference within a certain range.
And again, since we don't have a slag bearing process and we've got a really liquid puddle, we're going to use a push angle, right? So we're going to have to push that gas to cover that puddle, right? We usually have what, about 5 to 15 degree push,
Usually
and just real gentle, but we want to have some sort of forward angle on that, okay? Let's see what you got.
Ready?
Man, that sounded great. So you can see that Gabe's got a lot steadier hand in mine. A couple of decades in the trades versus a couple of decades behind the computer will do that for you. He's got a really steady hand. You can hear that in the weld he's making. So the beauty with this process, right now we're demonstrating the spray transfer, but you should be able to walk through your shop and be able to hear what the welders are doing if they're doing the GMAW process. Especially if it sounds like baking crackling, that's going to be your short circuit transfer, right? So we want to be mindful of that. But again, you can have that really distinct sound to it, and it has a really, really fluid puddle, all right?
There you go, buddy. See what you got.
Well, it's not going to be that smooth, I can tell you that much.
Pretty good there, Logan.
It's not bad. I don't know if the camera can get in on this, but if we notice some of the, oh, that weld right there's got some porosity in it. But if we can see some of these brown speckles on here, so those are actually referred to as silica islands. So that's not slag, that's a deoxidizer that is added to our solid wire. And its whole job is to remove oxygen from that weld puddle. So seeing those silica islands is a good thing, all right? They're really easily cleaned off. Just take that hand brush and they should pop right off. Of course, now that I'm on camera, they want to be stubborn, but they come right off. It's always good practice to clean between our weld passes and not let those build up too big. And again, you can see I had some porosity on this end, so maybe I didn't clean that base plate too well. So the beauty of this process is you've got really good deposition rates, you've got a lower barrier to entry for skill, and again, you know, we're running a continuous weld. You can see that we didn't have to stop halfway through to clean any slag. So this is where GMAW really shines. So Gabe, thanks again for joining me today to do a little bit of gas metal arc welding. Thank you.